Hi everyone, thank you for taking your time to actually take a look at this video. In this video, we are actually going to be predicting the difficulty of the text using machine learning. What is actually meant by readability is nothing but how difficult a given text is. And this dataset was taken from Kaggle from this particular website, and it is a computation data. Therefore, we are not given a full understanding about the approach or about the data. Here we take a look at the problem statement. We take a look at a list of things that we would be doing, and we do have a large number of articles and materials available, and it can be really useful if we are able to predict from a text how difficult it is. We are already given the difficulty scores of various texts in the data, and then we need to extract some useful insights from it so that we'll be able to predict in the future how many or how difficult the given text is. We take a look at machine learning and deep learning, which are the two fields that we would actually focus on in order to predict the difficulty of the text. Furthermore, we would also take a look at natural language processing, which is an important part in machine learning, where we try to divide the overall data and then make use of the language and convert it into a form of a vector before we give it to the models. In order to convert the given text into a vector, we use various vectorizers like count vectorizer, TF-IDF vectorizer. We also use average word to vec along with the TF-IDF word to vec. After converting all of these into the form of numerical vectors, we are now going to use machine learning models. We do have a list of machine learning models such as deep neural networks, linear regression, k-nearest neighbors. We have PLS regression. We also use decision tree regressor and followed by gradient boosting regressor. And after taking a look at all the predictions, we also get a few set of outcomes, which are nothing but the best encoding techniques or which machine learning model performed the best. Based on the outcomes, we see that TF-IDF word2vec was performing the best, along with gradient boosted decision tree was the best performing machine learning model. The future scope of this project would be to actually integrate it in various tools such as Microsoft Word or Microsoft Presentation, so that people can basically get the difficulty scores of their essay or about their presentation, and they can take action accordingly. We can also take additional text for the data from Wikipedia, and we also should label the output, which is the difficulty of the text, and we can also give that as an input to our models, and it can learn accordingly. Okay, now let us get started with the Jupyter Notebook, where I have provided the code for this. It's let us wait for some time, it's loading up, and this is the introduction, and we take the metrics like the mean squared error and mean absolute error, and this is the source of the data. Thanks to this data that I was able to make useful predictions. This is the introduction. This is the exploratory data analysis, which is the first part of machine learning. We are also creating new features with the use of various functions and also taking a look at plots like scatter plots. Finally, we take a look at machine learning models like PLS regression. We do have neural network model. We also take decision tree regressor. The final thing is to use the right kind of vectorizer so that we can convert a given paragraph or a text into a form of a vector before we can give it to the model for prediction. These are some of the libraries that we would use in the beginning, followed by taking a look at the training path and the test path. We read the data, we store the data in the df train and df test, along with taking a look at all the features and finding out if there is any missing value or if there is a null value in the data. We also check the memory usage, because if the memory usage is quite a bit, it can be hard for training purposes. Therefore, we always monitor the memory usage. In our case, it's not so big, therefore we can continue with using our own system. This is how we take a look at all of that. We read the first 5 rows. Here we do have the text, we have the difficulty, we have the standard error, This is just an ID to give an indication. Note that the target, which is the output variable, is in this form. It is standardized. They did it because we shouldn't get to know the actual difficulty of the text, because it can lead to mishandling the data, and this is a computation data. That's why they have provided just a converted data. But from this converted data also we can just get an understanding about the similarity between words and the difficulty. We check the missing values. The white segments indicate the missing value. Here we do find a lot of missing values for URL legal along with the license. All the other features are not missing. We create useful functions and take a look at the plots, and we take a look at the distribution of the target or the output variable, and we can see that it's pretty much standard distributed. We take a look at the standard error values as well, and we use a word cloud function. Basically, a word cloud function helps us to know the frequency of a particular word by the size of it. To illustrate, for example, if we take one, which is one of the words in our text, it shows that it occurs mostly or more frequently compared to the other words. There are very few occurrences of the word like small or now or good. Therefore, taking a look at the word cloud can give us a good understanding about the presence of various words. We also perform, after performing exploratory data analysis, we also perform pre-processing or feature engineering to extract various things from the text. We define a few set of functions which will basically take a look at the total number of sentences in a given text or the total number of words, along with the total preprocessed essay length and the text shortage and a few others, and it returns us the final preprocessed data. After taking a look at that, we just plot it to find out if there is any linear relationship between various features. And we do find that the word length is actually quite correlated with preprocessed essay length and so on, because we can basically draw a straight line. We also take a look at the heat map, which gives us the correlation between various features. We take a look at the scatter plot to see the difference or to see if there is any linear relationship between these two features. We also take a look at the preprocessed essay length and the number of lemmas to check if there is any strong correlation between these two features. Finally, we take the number of sentences and sentence length to find out the relationship. We extract a few useful features, and we check if there are any null values in the data, along with taking a look at various other features. And we also do the same analysis. We take the heat map. We do all of these pre-processing steps which are important. I'm just skipping through the code because I'll just give the link to this repository so that you can analyze the code in greater detail, where I also explain in with a good understanding, and I explain the type of steps that I've taken. We do all of these. We use TensorFlow, and we use TensorFlow because it is actually a deep learning network which can actually be used for predictions of regression tasks. We do all of these. We perform min-max scaling. We use the TF-IDF vectorizer, count vectorizer, along with a few other vectorizers, and we split the data into training part and the test part, where training part contains around 70% of the data and the remaining 30% is the test data. We train the neural network and we try to minimize the mean absolute error. Similarly, we do the TF-IDF vectorizing, and we take a look at the regression plot. This is the actual and this is the predicted. Note that the closer these lines are, or the closer the spread is, it means we are doing a good job in giving the right predictions. It does a decent job. Neural networks does a decent job. We also go with linear regression, k nearest neighbors, and we plot it, and even these plots show that they are doing quite well. We take a look at PLS regression. It also shows that there is quite not a lot of spread in the data, which is good. Now we take a look at decision tree, and decision tree here isn't performing that well as we generally expect a decision tree to perform. it is useful to consider that not all the models will perform the best in most of the tasks. Like, we do not have a clear winner every time which model can be performing the best. We also take a look at gradient boosting regressor, and we see that it's quite similar. We did a great job, and we import the glow vectors, which is also an important consideration. And finally, we train the neural networks over many epochs to see how the loss has been reducing with the model training. As we keep increasing the number of epochs, the training loss will reduce as we expected, but the cross validation loss might not be going as low as we wanted, because in this case our model might be overfitting, where the training loss is going significantly lower than the test loss, which can be a sign of overfitting, as we see here. We do the same thing for neural networks, and take a look at the TF-IDF vectorizing. Similarly, we do a regression plot, and we see that in this case we did a very good job, because the predictions and the actual values are quite close. We can therefore say that this model is actually performing the best. And this is the conclusion from the notebook, and this is how I have worked, where we first started with the feature engineering, exploratory data analysis, using various vectorizers to convert natural language process text, and finally we use various models to predict what can be the difficulty of a given text. We have seen the future scope of the project as well, where we can include more information from Wikipedia and other sources, which will further improve our analysis and our predictions. Thank you for tuning in, and please don't forget to subscribe, and thank you.